Okay, in section 12.2, the first thing we're going to look at is surface area of prisms and cylinders. So how do we find the surface area of prisms and cylinders? First, let's remember a prism has two bases. So here on the figure on the right, if you look at this, we're going to have two bases. The parallel sides are the bases. So we've got the base up here, and then we've got a base down here on the bottom. And remember, the sides are connected by connecting the vertices. From the top base to the bottom base, we connect vertices. So all the sides on a prism are going to be rectangles. All right, so let's start looking at how we figure these things out. Next slide says, a prism is a polyhedron with two congruent parallel faces called the bases. So they're parallel sides, which we just talked about. The congruent faces then are the bases. Again, we just talked about. Let's look at the next slide. The lateral faces are those parallelograms that are formed by connecting the corresponding vertices of the bases. So that's what I had showed you when we connect the top base to the bottom base of their vertice. We get parallelograms. Now, in most of the cases that we're going to look at, like I had said, rectangles, they will be rectangles. Will they always be rectangles? Not necessarily. And we'll talk about what that means in a minute. We may not get one that's standing, I guess you could say, standing up straight. It could be a figure that's angled. Not angled, but maybe that's leaning. And so it's two bases. I can't draw very well, but I think hopefully you'll get the idea that the two bases could be down here, top and bottom. They could be parallel to each other, but the shape itself might be tilted just a little bit. And so that's why those sides would be parallelograms. Okay. Okay, next slide. Surface area is the sum of all the areas of all of the faces. Top, bottom, all the sides. Now the lateral area, when we talk about lateral area, it is the sum of all of its lateral faces only. So you might want to also write in no bases. So we find the sum of all of the sides, the lateral faces, and we don't include the base, the top or the bottom base. Okay, let's look at a net. A net is when we open up, I should say it's the two-dimensional. It's a two-dimensional representation. Okay, it's a two-dimensional representation of all the faces of a polyhedron. And so if we look at this rectangular prism here on the left, if we opened it up, if we cut along a few of these sides, and then we opened it up and laid it out flat, this is what it's going to look like. And so that's what a net is. It's that picture laid out flat in 2D rather than in 3D. And to find all of that, realize that we have, okay, so let's take a look at this net and figure out what the surface area would be. And if we look at all the pieces, realize that we have two of these two here, top and bottom, that are 5 by the height, which is 6 right there. So that piece is 6 centimeters. And then we have two, let's do this one in green, here and here that are the same, 5 by 2. And then in blue we have two of this side, that's 2 by 6. So if we do each one and add them up, we'll get the dimensions. So let's do the red pieces, which on the shape would have been the top and the bottom. So I have top and bottom. Which were 6 by 5. That gives me 30. All right. The blue one is the left and right. Okay, the left and right sides are 2 by 6. and so that's 12 for one of them. And then the green ones were front and back. I'm going to abbreviate those. And the front and backs were 5 centimeters by 2 centimeters. And so that gives me 10. Now remember, we have to do 2 of each. So 2 times 30 plus 2 times 12 plus 2 times 10. And if you add all of them up, multiply those and add them all up, we're going to get 104. And since we're talking area, you go back up here and look, it's a surface area. Area is centimeters squared. Area is a squared unit. Okay, so let's look at right prisms. And a right prism is where each lateral edge is perpendicular. I use the symbol perpendicular to both bases. Okay, and so that makes it a right rectangular prism. A right prism where the lateral edge that we go from top to bottom is perpendicular at the bases. And so then on an oblique prism has lateral edges, and this is what I was explaining on that first slide, lateral edges that are not perpendicular. So kind of slanted. Okay, so how do we find the surface area of a right prism? Well, a right prism's surface area formula is 2, and the capital B, and the capital B means bases. I have 2 bases, so I'm going to find the surface area of each base and multiply by 2. And to that, I'm going to add the area of each lateral face, which is perimeter times the height. So perimeter, that's this piece. Around the base is your perimeter. Perimeter is that distance around one base. That gives me the perimeter around the figure. And then if I multiply by the height, this piece right here, that's going to give me all of the lateral faces right there. Perimeter times height is the lateral faces. So let's look at an example. No, well, first let's go and define these. Bases, capital B, means area of base and the P is your perimeter. H is the height. Okay, so let's look at the example on the right. We need to find the surface area of the right prism. So in the first thing we're going to want to do, we've got one side here is 7.05. So I know each of these sides is 7.05. I know it is a right rectangular, or not rectangular, pentagonal prism. It's got a pentagon for the bases. And we know that the pentagon, from all of the angle measures being the same and all the side measures being the same, and that's marked with the 1 tick mark, that makes that a regular polygon. So each side is 7.05 feet. So the first thing I can do is go ahead and find the perimeter. The perimeter around your solid is the distance around one base. So my perimeter is 7.05 times 5 sides. And that's going to give me 35.25. Okay, now I've got to find the area of a base, which if you remember, the area of this base, and I'll write it over here, area of the base, it's a pentagon. So what I'm going to get is apothem, lowercase a, times perimeter, and divide by 2. And that's how we're going to find the area of one base. To do that, I'm going to have to draw in the apothem on that this isosceles triangle. So we don't know the apothem, but I do know that one side of that isosceles triangle is this, 6 feet. And then if I divide one side, 7.05 by 2, I'm going to get, for one side, 3.525. Okay? And so I can do Pythagorean Theorem. So my apothem is going to be the square root of, okay, since the 6 is your hypotenuse of that right triangle, we're going to get 6 squared minus 3.525 squared. And so actually I didn't need to draw that square root quite so far, because what we're going to get is that that's approximately 4.86. Okay, and so that's my apothem, 4.86. We've got a perimeter. And so my surface area for this figure is going to be, okay, now that we're in this part of the formula though, let's go find the area of one base of this pentagon, the pentagon shape that is your base. So the area of that base, I'm going to continue this one in red, is my apothem, 4.86, times the perimeter, and the perimeter was 35.25, divided by 2. So we get the area of one base, and I get 85.657, so let's call that 85.66. So that's the area of one base. So let's go back over here to the formula and plug that in. 2 times a base, one base, which is your 85.66, plus the perimeter, 35.25, times the height. And that height, let's go in red and show you the height because I've drawn all over the figure, is this right here, that height right there. And that's 9 feet. Kind of drawn all over it, but that's it right there, 9 feet. Okay? And so we're going to go figure that out. Now, here's something to pay attention to. If you're plugging this into your calculator, you would have to put the whole first piece in parentheses, and the whole piece back here in parentheses, multiply both sides, and then add. So make sure you pay attention to that and the way the calculator is doing it. We have to multiply the first two, multiply the second two, and then add at the end. Okay, so I got 171.32 for the first piece and 317.25. So my surface area when I add these two together is 488.57. And this was feet. It's an area, so feet is squared. And that's your answer for the surface area of that right prism. Okay, Pentagonal Prism. Just a short little word about nets and thinking about what they look like when we lay them, when we open them up and put them out flat. For that Pentagonal Prism, what we would have, and I'm not the best artist, so you guys are just going to have to go with me here. We'd have 2, 3, these should all be the same if I could draw. We'd have 5 sides, and then from one of those sides we'd have, oh, I really can't draw. We'd have pentagons. That does not look like a pentagon, people. I am really sorry. We'll have to get somebody that can draw better to do it. Okay, there's a pentagon on the bottom. Think about that same one here being on the top, because that's what it would kind of look like. We'd have these pentagons off of each. And so if I folded up those the pentagons and then rolled them along the edges, that's about what your net would look like. I really don't want to try to draw any more nets. Not very good at it. There's some more pictures probably in your book. Okay, let's talk about cylinders. A cylinder is a solid with congruent circular bases. The bases are circles. And remember, you have 2 bases, and they are parallel. They are in parallel planes. A right cylinder is where the segment that joins, a segment joining the centers of the bases. Is perpendicular to the base. Okay, and so that line will be perpendicular. It'll be perpendicular at the top base and at the bottom. Here is your formula for the surface area of a right cylinder. We still have that the surface area is going to be 2 times the area of one base, and we already talked about what capital B is, plus, and this is circumference, right, because it's a circle on the bases, so around the base is not perimeter here, it's circumference, times the height. So really it's the same formula, but with circles, the distance around one base is a circle, so it's circumference. And let's further look at this and say, okay, we've got a surface area of 2 times a base and one base, but let's think about the base. It's a circle, right? So the area of one of those bases is pi r squared plus my circumference. Well, the circumference of a circle is 2 pi r times the height. And so for a cylinder, we get this more specific formula. It's the same formula. If you think about it, it's the same one. You just have to remember to put in each of the formulas for the area of a base and then what the circumference formula is for a circle, because these are circles we're dealing with now. Okay, let's look at these compact discs stacked up, and we're going to wrap this stack of 20 using shrink wrap. Each disc is cylindrical and it has a height of 1.2 millimeters. This has a radius right here of 60 millimeters. Okay, so what is the minimum amount of shrink wrap needed to cover the stack of 20 discs? Okay, let's look at what this height of this cylinder shape might be. And my height, if I look at 20 compact discs that are each 1.2 millimeters tall, then my height should be 24. All right, so we really have all the information we need. My surface area is going to be 2 pi times the radius, 60 squared, plus 2 pi times the radius, which is 60, times the height, 24. So we're going to multiply these and then add them together. If we want to do this in terms of pi, okay, so I first did this in terms of pi. I got 7,200 pi here on the first term. I'm going to add to that 2,880 pi. And I put all of it in my calculator. Now we can add the two numbers together to get the amount we'd have for pi, which would be 10,080 pi. But if you plug it all into your calculator, 7,200 times pi plus 2,880 times pi, you're going to get this, approximately 31,667.3 millimeters squared. And that's the surface area of that stack. Okay, let's do one last example here. The surface area is given to us here, 157.08 square meters. So let's remind ourselves of the formula. Surface area for a cylinder, and this is a cylinder, 2 pi r squared plus 2 pi rh. And this is what I keep telling you guys in class. Write down your formulas. Plug in what you know, and then you can just solve for what you don't know. What variable that you don't know you can solve for. Surface area is 157.08. So write it in for S. That's the surface area. 2 pi, and I have a radius, which is 2.5 squared, plus 2 pi times 2.5 times the height. And there's what we need to solve for. Okay, so let's condense this somewhat. 2.5 squared and then multiply by the 2. So I'm going to do 2.5 squared and multiply by 2, and I'm going to get 12.5 pi. plus 2 times 2.5 is 5 pi times h. And so now we need to start solving. I've got the variable here in this term right here. So this whole second term that has the variable in it, I'm first going to have to get on the right-hand side. That's going to mean subtracting the 12.5 pi. Since I have it positive on the right, I'm going to subtract it from the left. 12.5 pi. Got to subtract those on both sides first. Since we started with decimals, we're going to go ahead and put this in decimal form. So 157.08 minus 12.5 pi is going to give me 117.81, and that equals 5 times pi h. Now here 5 pi is being multiplied by h, so to get rid of 5 pi we're going to have to divide out the 5 pi on both sides. And since I'm dividing by 5 pi, and you can go ahead and put in that pi, 5 times pi. If you plug this into your calculator, let me show you here. If you plug that into your calculator, you must put parentheses around this 5 pi first when you put this in your calculator. 117.81, and then divided by, in parentheses, 5 pi. If you don't do that, you won't get a correct answer. It's going to divide your 117.81 by 5, and then it's going to multiply by pi if you don't put in the parentheses. And you will get a wrong answer. So make sure you're putting that in parentheses, or in this step right here, you could go ahead and write 5 pi as its decimal form. Okay, so that's just a tip there. So once I do this and I do the division, I'm going to get 7.5 equals h. The 5 pi's, when I divide it out, go away. And I'm going to get 7.5. So my height is 7.5. And this is in meters. So the height is 7.5 meters. And that's your answer. All right, now we can look at some on your worksheet, which we will do in class.